Nicole Dionisio, and now we're going to discuss atom. Atoms are the basic unit of matter, and it is the defining structure of elements. The term atom comes from the Greek word atomos, which means indivisible, because it is once thought that atoms are the smallest thing in the universe and they could not be divided. But now we know that atoms are composed of three subatomic particles, which are the protons, electrons, and neutrons. To start our discussion about the proponents of the atomic theory, let's go with Democritus.
Democritus, known in antiquity as the laughing philosopher because of his emphasis on value of cheerfulness, was one of the two founders of ancient atomist theory. He elaborated a system originated by his teacher Leucippus into a materialist account of the natural world. The atomists held that there are smallest indivisible bodies from which everything else is composed, and that these move about in an infinite void. Democritus lived in Greece from about 460 to 370 BCE. Like many other ancient Greek philosophers, he spent a lot of time wondering about the natural world. Democritus wondered, for example, what would happen if you cut a chunk of matter such as a piece of cheese into smaller and smaller pieces? He thought that at a point would be reached at which this cheese could not be cut into still smaller pieces. He called these pieces atomos, which means indivisible in Greek. This is where the modern term atom comes from. Next, Aristotle. He was a Greek philosopher and scientist. At 18, he joined Plato's Academy in Athens and remained there until the age of 37. Concerning matter, Aristotle had a view that was rather foreign to the modern concept. He believed that there were only 5 elements: air, which was light; earth, which was cool and heavy; water, which was wet; fire, which was hot; and ether, which he viewed as a divine substance which made up the stars and planets. Aristotle believed that all matter was made up of either one of the elements of water, air, earth, and fire, or combinations of these 4 elements, with the exception of stars and planets, which were made of ether. Aristotle's ideas were used by the Catholic Church in the Middle Ages, and the people who followed Democritus were shunned or killed. Third in line, John Dalton. He was a renowned English chemist, physicist, and meteorologist. His most famous contributions were his atomic theory and color blindness research. Dalton suffered from color blindness and offered the first scientific description of this condition. His greatest scientific contributions were in chemistry. John Dalton believed in Democritus' work. His theory consisted of 4 basic ideas. Number 1. All matter is composed of atoms that are indivisible. Second, all atoms are identical in properties such as size and mass. Number 3. Atoms are rearranged as a chemical reaction occurs. Lastly, compounds are formed by combination of multiple atoms. In 1886, Eugen Goldstein noted that cathode ray tubes with a perforated cathode emit a glow from the end of the tube near the cathode. Goldstein concluded that in addition to the electrons or cathode rays that travel from negatively charged cathode toward the positively charged anode, there is another ray that travels in the opposite direction, from the anode toward the cathode. Because these rays pass through the holes or channels in the cathode, Goldstein called them canal rays. He assumed that these new rays had the equal and opposite charge of the electron. He also determined that the mass of the proton is 1,840 times heavier than an electron. J.J. Thomson took science to new heights with his 1897 discovery of the electron, the first subatomic particle. He also found the first evidence that stable elements can exist as isotopes, and invented one of the most powerful tools in analytical chemistry, the mass spectrometer. His work proved one of Dalton's ideas wrong. The atom was not indivisible, but in fact made up of multiple components. The discovery was made when he conducted an experiment with a cathode ray tube. When an electrical current was passed through, glowing material could be seen. When he put two electrically charged plated on opposite end of the tube, the light was bent on the positive plate. Thomson thought that the atom looked like raisin pudding, a ball with negative electrons clumped on it. Ernest Rutherford. First Baron Rutherford of Nelson was a New Zealand chemist who has become known as the father of nuclear physics. In 1911, he was the first to discover that atoms have a small charged nucleus surrounded by largely empty space and are circled by tiny electrons. He is also credited with the discovery of proton in 1919 and hypothesized the existence of the neutron. He was awarded the Nobel Prize in Chemistry in 1908 for his investigations into the disintegration of the elements and the chemistry of radioactive substances. In the same year, Rutherford proved Thomson's atomic model to be incorrect. He is famous for his gold foil experiment, which stated the existence of protons. He shot alpha particles at the gold foil and observed where they hit. Most were reflected, while the rest bounced off into the different directions. Niels Henrik David Bohr was a Danish physicist who made fundamental contributions to understand the structure of atoms and to the early development of quantum mechanics. He also introduced the idea that electrons travel in discrete orbits around the atom's nucleus, the chemical properties of the particular element being largely determined by the number of electrons in the outer orbits. In addition, he proposed that an electron could drop from a higher energy orbit to a lower one, emitting a photon of discrete energy in the process, which became part of the basis for quantum theory. James Chadwick is best known for his discovery of the neutron in 1932. A neutron is a particle with no electric charge, along with positively charged protons, makes up an atom's nucleus. Bombarding elements with neutrons can succeed in penetrating and splitting nuclei, generating an enormous amount of energy. In this way, Chadwick's findings were pivotal to the discovery of nuclear fission and ultimately the development of atomic bomb. For this epoch-making discovery, he was awarded the Hughes Medal of the Royal Society in 1932 and subsequently the Nobel Prize for Physics in 1935.
And those are the proponents of the atomic theory. I hope you learned something from me today. That's all, and thank you for watching. Bye!